Hey guys, welcome to EC Orbit. The subject we are going to see is digital electronics. In that, the topics to be discussed is number representation, codes, Boolean algebra, and then basic gates. Number representation, there are four types of number representation, that is unsigned magnitude, sign magnitude, sign 1's magnitude, sign 2's magnitude. For unsigned magnitude, the range is between 0 to 2 power n minus 1. For sign magnitude and sign 1's magnitude, the range is between minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. And then for sine 2's magnitude is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. For example, in competitive exams, they may ask like, they will give the n value like n is 8. We need to find the range for unsigned, sign, and sign 1's magnitude and sign 2's magnitude. So memorize these all. Codes. Codes are classified into two types, weighted code and unweighted code. Weighted codes is a position weighted code. For example, binary, octal, hexa, BCD 8421. Binary means 0 and 1, octal means 8, hexa means 0 to 16, that is 0 to 15, and then BCD means 0 to 9, binary coded decimal. Unweighted codes are non-weighted positional system. Example, gray code, XS3 code. And then alphanumeric codes. Alphanumeric codes are ASCII code and EBCDIC code. The expansion of ASCII is American Standard Code for Information Interchange. EBCDIC expansion is Extended Binary Coded Decimal Interchange Code. BCD code is already we seen that. XS3 code is nothing but adding 3 to the BCD code, we will be getting XS3 code. And then gray code. Gray code is unweighted code. The another name for gray code is reflected code or cyclic code. It is a minimum changing code. That means like single bit will be changed in each and every consecutive stages. Binary to gray code conversion is, for example, 4 bits are there, B3, B2, B1 and B0. MSB will be same, like G3, B3. For G2, we will be XORing B3 and B2. For G1, we will be XORing B2 and B1. For G0, B1 and B0 will be XORing. We should do XOR operation between 2 bits. For example, 1, 1, 0, 1. In this case, the MSB will be same, 1. For next stage, we will be XORing the first 2 bits and consecutive steps we need to do for further. Equivalent logic diagram for gray, binary to gray is, see this diagram. And then gray to binary. Gray to binary means like it is slightly different than binary to gray. In binary to gray, we will be doing the consecutive bits XOR operation. Here also the first bit is same. For G3, the MSB will be same. We will be writing B3. And then for B2, what we'll be doing is, we'll be XORing B3 and G2. And then for B1, B2 and G1 should be XOR. For G0, B1 and G0 should be XOR. See this example, 1, 1, 0, 1. First bit, MSB bit, will be directly writing as 1. And then for further bits, we'll be XORing that 1 and then XOR with 1. 0. In XOR operation, same means 0, different means 1. That is 0, 0, 0, 0, 1, 1, 1, 0, 1 and then 1, 1 also 0. Equivalent logic diagram for gray to binary. And then Boolean algebra. Boolean algebra is important. In digital electronics, we'll be using these all. Commutative law, associative law, distributive law. Commutative law in the sense, A plus B is equal to B plus A. A dot B is equal to B dot A. Associative law means A plus B plus C is equal to A plus B plus C. A dot B dot C is equal to A dot B the whole C. And then distributive law is A bracket of B plus C is equal to AB plus AC. And then identity law. Identity law means 1 and A means A. See this all table. In this, De Morgan's law is very important, and then inverse law is also important. Idempotent law is important. Absorption law also important. Absorption law is mostly asked in the competitive exams. Like if you memorize this absorption law means we can easily solve in further problems. Basic gates. Basic gates are nothing but and, or, and not. These are the basic gates. Universal gates are NAND and NOR are universal gates. Why we are saying NAND and NOR are universal gates means with the help of these NAND and NOR gates, we can build any other type of gates. See this symbol. Each and every symbol is important. AND gate is like this symbol. If we put one bubble to the AND gate means we will be getting NAND gate, and if we put one bubble to the OR gate means we will be getting NOR gate. And also this expression is very, very important. And then for these all logic gates we will be going to see truth table. For NOT gate, if we are not as like, if we are giving 0 means the output will be complement of that. For example, if we are giving A as input means A bar will be the output, not as complement gate. And then AND is like if your AND expression is AB for 0 0 0 0 1 0 1 0 0 1 1 1. NAND is nothing but complement of AND. So for 0 0 0 1 1 0 we will be getting 1. For 1 1 only we will be getting 0. OR means A plus B. For 0 0 we will be getting 0. 0 1 1 1 0 1 1 1 1. NOR is the complement of OR gate. So A plus B the whole bar is NOR. For 0 0 we will be getting 1. Only for 0 0 only we will be getting 1. For other all combinations 0 we will be getting. XOR is kind of A XOR B. Already we see in binary to gray and gray to binary conversion we will be using XOR operation only. So 0 0 0 0 1 1 1 0 1 1 1 0. Same combination of input we will be getting 0. For different combination of input we will be getting output as 1. XNOR is the complement of XOR gate A XOR B. See here, for same combination we will be getting 1. For different combination we will be getting 0. So see once and memorize this table. Thank you for watching this channel. Kindly do share and subscribe. Stay tuned for more videos.